Good afternoon, everyone. Hope everyone's well, enjoying the day, first day. Please welcome to the stage Pearl and Alex talking about integration with NSX. Thank you.
Thank you, everyone. So we're going to be talking about SDN in general and NSX in particular. So first, who we are. Been working with CloudStack for over 10 years, built quite large cloud, now work at Shablue Cloud Architect. And
okay, so I'm Pearl. Have been with Shablue and with CloudStack since 2019. I'd like to consider myself a proud committer, and yeah, that's me so far.
And she's a hero. She moved to Canada, so she has to wake up 5 a.m. to join team meetings. That's I couldn't do that. That's a commitment. So, quick introduction to SDN in case anyone haven't used one. Put very simply, now SDN, you decouple the data plane from the control plane, and you manage all of that via software. That's basically what SDN is in broad definition. There's a very rich ecosystem of SDN vendors from open source to totally closed source and in between with different capabilities. Highlighting there, Tungsten Fabric, because there's one that has actually been integrated with CloudStack. Been there since 4.18. Was supposed to be on 4.14 and got delayed a few times. Is there on 4.18. And I know there are probably questions about the future of Tungsten Fabric. Let's take that offline. There will be some news tomorrow about that. Tungsten Fabric, SDN, there you have the physical layer, your switches, everything, just typically layer 2, and your core routers. On top, the logical, where you define your policies, your tunnels. You actually program how your packets go from VM A to B. In the integration Tungsten Fabric, we have new isolation method. There's a couple presentations on Tungsten Fabric online. Anyone interested can have a look at that or ask me. And it works just for KVM, so a bit limited. And now, new integration, VMware NSX, which hopefully will be on 420. That's what we are aiming for. And of course, if I'm talking about SDN, VMware NSX is SDN, which will bring us to a richer environment with Tungsten and VMware NSX on CloudStack. Can create some rich, much richer topologies there. What is NSX? SDN, with all the characteristics of SDN, very rich, lots of features. It started on Stanford University, then the guys as a research, postdoc research, then they created the company in Syrup that was then sold to VMware for obscene amount of money, became NSXV, then NSXT, now it's just NSX4. So typical story. Public research becomes a private company. But how does NSX actually work? It has two types of logical routers. The first one is a tier 0 gateway that deals only with your south-north traffic. It peers with your core routers, BGP, OSPF, whatever routing protocol. And south, it connects to tier 1 gateways, which deal with the east-west traffic, VM to VM, and with tunneling on using Geneve or VXLAN, depend how you configure that. That's outside what CloudStack manages. It has a concept of transport zones, which defines a network boundary. Can be seen as a label. Networks which are in the same transport zone can communicate. Simply that. Can be tunneled, NVGRE, VXLAN, etc., or can even go through traditional VLANs. So how NSX integrates with ESX? And yeah, it's confusing to pronounce both together. Sometimes gets very confusing. You can see there your VM kernels. When you configure a host for NSX, it creates a VTAP interface, virtual tunnel endpoint, which is the IP that will be used to encapsulate traffic on UDP on that interface. And there's another VM kernel for internal traffic. The tier 0 gateway, it has there your BGP peering, south-north traffic, and tier 1 gateways connect to tier 0 gateways. You can have multiple tier 1 gateways connected to the same tier 0 gateway. The tier 1 gateway itself running directly on the kernel, so scales horizontally. More hypervisors you have, more capacity you have, and it advertises routes to the tier 0 gateway that then advertises upstream. And then you have the segment. You attach a segment to a tier 0, to a tier 1 gateway. You can also attach to a tier 0, but that's out of scope right now. So a segment is just a network. It shows in a DV switch, just like a network. Instead of VLAN, you have a VNI. And our project was to create VPCs in NSX. And it looks like this. You have a certain account, a VPC, 3 tiers connected to a tier 1 gateway. That tier 1 gateway connects to a tier 0 gateway. That's the functional equivalent of VPC. So that tier 1 gateway does the same job as the VPC virtual router. And now that's when I hand over to Paul, who did actually all the work.
And Nicholas. Okay, so going on to speaking about the implementation of VPCs in NSX. Before we proceed, essentially, at looking how NSX is ACS and NSX integrate, let's briefly talk about how one can easily develop and integrate or plug in a network provider into CloudStack. So on a high level, from the implementation of a network provider or a network element, you'd have a network element, which is where you define what are the services that you offer, like in this case, port forwarding, load balancing, etc. And then you have the server resource. This is who is actually responsible for sending out the commands to your actual manager and performing the necessary operations on NSX. Then you proceed to implementing the guru. Guru is the brains where the whole network is actually designed and initialized. In CloudStack, we basically highlight the various life cycle, which is the design where the network is actually created only in the database. Then we set it up. Setup is a new stage that was created with NSX because we wanted to immediately create the segment which is equivalent to a network in CloudStack in NSX rather than wait for it to be created at the time of the first deployment of the VM, which is how traditionally CloudStack works. And then we go to the implementation phase where all the metadata is updated in the database in case of NSX. And finally, allocation. Allocation is where the NIC is created in the VR. When a VM is deployed, then a NIC is created in the VR with an IP from the segment range. And this is also where the DHCP relay config is set up, and we'll understand why that is needed to be done. Moving further, now is when you have to explain to CloudStack how it can talk to this network element that has been created. So firstly, download all the necessary dependencies. If it is proprietary packages, then we have a separate repository where it needs to be set up. For every network element, there is a one-to-one mapping, so you need to define a provider as well. And then you have to instruct CloudStack that there is a new provider, so point it to the relevant POM dependency, and finally for CloudStack to actually be able to provide you the functionality you need to add this provider to the physical network. So on a high level, that's what we've done, simple. So next is offering. Offering is, it basically defines what your network provider is capable of doing. So with NSX, we have two flavors, the rooted and the natted mode. Let's delve into first what the natted mode, which is the general way in which CloudStack operates. So in the natted mode, you'd see source NAT, static NAT, and all other functionalities are provided by NSX. But DHCP, DNS, and user data is provided by the virtual router. Also, to highlight, if you see the route advertisements, all NAT IPs are advertised in this mode. Visualizing how a NAT network would look like, on the right-hand side is what ideally would be what we'd like to design, how we'd like to design a VPC. On the left-hand side is what it looks like on NSX. And you see the source NAT IP. That is the source NAT IP is advertised as a single IP to the tier 0 gateway. So tier 1 gateway essentially is a much evolved, sophisticated VR in NSX. The next mode is the rooted mode. This is similar to how IPv6 is set up on CloudStack. Here, all the IPs of the segments and connected interfaces are advertised. And hence, you'll see the difference. Another config is enabled in the route advertisement here. And from the visualization point of view, you can see it's a single-tiered VPC, basically. Pretty similar to what it was previously, but you'd see no NAT rules being applied because the traffic is purely routed. Going into the VPC functions that have been implemented on the NSX side, so we have source NAT, which is translates the action on NSX side is SNAT, whereas port forwarding is DNAT with the port and public IPs being specified. The one-to-one NAT is basically similar to port forwarding, but without the ports being defined. And lastly, we have the load balancing, which is a little more involved. You have 3 components: the load balancer, the server pool, which has the members, that is your VMs that are getting added to the load balancer, and then the virtual server, which basically points to the public IP, and the server pool. Isolated networks in NSX are set up as a single-tier VPC network. And by enabling isolated networks, we've also added support for CKS with NSX. Going to VR. Now, as mentioned earlier, we still fall back or deploy the virtual router with NSX because some of the services like DNS, user data, etc., are provided by the virtual router. And in order to facilitate that, we set up the DHCP relay config on NSX so as to route all the traffic down back to CloudStack VR for DHCP. So essentially, the VR acts like how it acts in a shared network, does not come in the data path. So due to lack of time and not wanting to make a fool of myself, I'm just going to go through the screenshots of how zone creation is now enabled with NSX in CloudStack. 2 important global settings would be, firstly, the NSX plugin enabling global setting, which needs to be enabled for you to use NSX. And the next thing is the port management port group. There needs to be a management port group with a specific name for you to be able to register your hosts. The next is the same. We select core zone in advanced mode without security groups. Then just add the same old details of DNS and etc. No change here. But here is where the first change happens, where we add the isolation mode as NSX. And with NSX being added as isolation mode, you add the appropriate virtual distributed switches as the vSwitch names in the traffic labels. So here's where I'd like to highlight that with NSX, you need to use distributed vSwitches. Since we selected NSX as the isolation mode, we'll have to now specify the NSX controller details. And all these details highlighted here in the pretty colors, you'd see are prerequisites, and these need to be created much before you start with, it's outside the context of CloudStack. Moving further, now we have two separate public IP ranges, one's VLAN-based, solely dedicated for system VMs, and the other one which is solely dedicated for NSX. And then further steps, there are no changes. You go on with the pod management and all the other addition of primary and secondary storages, and then your zones up. If all things go well, you'd have your NSX provider connected with CloudStack, and you'd have an NSX-enabled zone. So a lot of this is what we've done, and we've enabled the services. So to quickly highlight what we've done and how the services map, I've logged in as a normal user. So let's go ahead and create a VPC and see how a tier 1 gateway is created on NSX. So as the VPC proceeds to be set up, it will take some time because the virtual router is also being set up at the same time. But if you go here, you'd see a tier 1 gateway being set up. So V3 was the pre-existing one. V5 is the new one that's being set up. Since we use the NATed offering, as highlighted earlier, you'd see all NAT IPs being selected and not this specific one. Since the virtual router is being continued to set up, do you want to go into details?
Yep. So here, as I explained earlier, we have the tier 0 gateway as well, and the BGP connectivity with the north-south traffic. And here's a really nice topology view of all of that. You can see here the 3 tiers of a VPC connected to a tier 1 gateway and to a tier 0 gateway. And here we can see how the firewall is going to work. This network has allow all by default. So you have all from the segment to any, allow any to the segment, allow, and any deny rules go on top of that. And the reverse if it's default deny, or if you create any kind of ACLs. Back here to networking, the tier 1 gateway was created. Let's see. Yep, VPC has been created. Go ahead.
OK, so with the VPC having been created, we can go ahead and create a tier 1. It's just
web.
Okay. Selecting the NAT mode. I don't remember.
No problem.
No.
You go explain it. I do it.
OK. I don't remember the subnet. So now when we go ahead and create the network, we'd see the segment immediately being created in NSX.
It's not really a live demo if it doesn't fail at some point, right?
0 at the end.
One. Gateway.
Yep. Thank you, guys.
Put web 1, because I think there's one with web. Okay. So that's why we didn't do the whole zone creation. So let's go, now that we have a backup plan, we have already created those the tier networks, which we already saw as segments on NSX. Yeah. So let's go ahead to the public IPs, acquire a public IP, and having acquired it, let's add a simple port forward rule. Okay, so having added that, let's go to the specific segment, tier 1 gateway, and you see the port forward rule being added for port 22 for the given public IP, which is 219. So all of the other services are set up in a similar way. The mapping happens. That's just a one-off. Ignore. And yeah, the floor is open for questions.
Very good, thank you. Any questions from the room? Here we are.
Thank you for your presentation. Did you implement the security groups over NSX? And you don't have any plan?
No, there's no security groups in VMware. Yes,
but with distributed firewall, you can
we use
implement it.
the distributed firewall as ACLs.
But you are using it over network. Do you have plan to use it over the VMs on the Linux?
Not so far.
Okay.
Maybe in the future, yes.
Thank you.
Okay, thank you. Real quick, just a question from the online audience. Are you using the old load balancer or the new NSX load balancer controller?
The old one for now.
Thank you. Simple answer. Marco?
I have a question related, for example, cross-zone. Is possible to implement it using both zone?
Absolutely. If your network's on the same transport zone, NSX will just tunnel the traffic. That's what it does by default. We actually need to add firewall rules to stop that from happening. But yeah, absolutely. That can be implemented in CloudStack later on.
Very good. Will this support VMware Advanced Load Balancer as well?
Hopefully, at some point.
Okay.
And this implementation for 420 is the standard load balancer.
Perfect, thank you. Anything else from the room? All right.
Great presentation, Alex and Pearl. You might have to Pearl check. Maybe you ran out of the number of networks allowed for an account, right? So something like that. But still, your presentation demo is still very good. I have a question. You mentioned in the zone creation that you have to allocate and dedicate specific IP ranges to system VMs. Why is that?
So NSX, the public IP range is used for source NAT, any of destination NAT, any kind of NAT. It's advertised as a /32 from the tier 1 to the tier 0 upstream. So there's no gateway. It's just really advertising one network. And that wouldn't work for the public interface of the virtual router. We actually could implement that way. That's how it works in Tungsten Fabric. And that's a nightmare to manage. Then you have to advertise your public range outside. So we learned from the mistakes of the Tungsten implementation and kept those two separate ranges. So system VMs have their own VLAN-based public IP addresses.
Okay, thank you. Any more questions from the room today? Okay, got one more from on the online audience. Two-part question. NSX interactions work with VMware and/or KVM?
VMware.
VMware.
Yeah.
And
bare metal for CKS.
bare metal for CKS.
Yeah.
Why you apply DFW rules to global DFW? Build, group, and assign rules to only the tier 1, I think. You didn't hit the limits of the rules you can use. I'm not sure. Not sure what the question is in there.
Okay, this is a work in progress. The firewall implementation is still being implemented, so there will be some changes there. We'll probably have change that.
Okay, thank you. Anything else for the Pearl or Alex? Thank you, Pearl. Thank you, Alex.